All right, we're going to look at the side splitter theorem today, developing more of our concept of proportions in triangles. So the side splitter theorem says that if you have lines that are parallel within a triangle, one line inside parallel to one of the sides, then it will divide the sides proportionately, okay? So instead of making two small triangles out of this, which would be TSU, so that would give us x and 5, and the larger triangle, TRV, which would give us x plus 16 to 15, we don't have to do x to x plus 16 and 5 to 15. We can do this now as x to 16 as 5 is to 10, or we can do x is to 5 as 16 is to 10, and we will get the same answers without doing all of this other work. Okay, so when we're looking at this, we can do x is to 16 as 5 is to 10. So we get 10x equals 80. So x equals 8. And we have our answer very quickly. All right, so we found out what x is. It equals 8. All right, in this next one, this is y, this is 12, this is 6, and this is 10. Again, we have parallel lines. One line inside parallel to one side of the triangle. So the side splitter theorem says that it splits the sides proportionately. So we can do 12 is to y as 10 is to 6, okay? And when we cross multiply, we get 10y equals 72, and y equals 7.2. Okay. Next, we're going to take a look at a theorem that we're familiar with for parallel lines intercepted by transversals, except that when we worked with this before, if we had two or more parallel lines intersected by numerous transversals, then what we found is that if the transversals intersected the parallel lines equally, any other transversal also would be intersecting those parallel lines equally. Well, this one's different. It says if we have three or more parallel lines and they intersected by two transversals, then the segments that are intercepted on the transversals are proportional. So in other words, A is to B as C is to D. You could even say A is to C as B is to D. So A over B, which we already did. Wait, I wanted to do this. A is to C. That's what I meant. A is to C equals B is to D. All right, so there's a number of different proportions you can set up, but you'll get the same answers. So if we're working with this one where this is 6, this is x, this is 9, SB is 5, BD is 12.5, and DT is y. We have a number of ways we can solve for x in the first place and then y. So we can do 6 is to x as 5 is to 12.5. All right, and 12.5 times 6 is going to give us 75, so we get 5x equals 75. So x is going to equal to 15. We could have also done 6 is to 5 as x is to 12.5. And again, you'll get 5x equals 75, so x is equal to 15. So you can see there are a number of ways you can do this. So let's get our 15 here. Now I tend to stick with what I'm given rather than use calculations I just calculated because if I made a mistake here, I will continue to make an error. So to find y, I'm going to stick with 6 is to 9. 6 is to 9 as 5 is to y. So 6y equals 45. Divide by 6, and y is going to equal 7.5. So 7.5. All right, so this kind of thing works with parallel lines cut by transversals. That just puts them in proportion. But don't forget, if they were cut equally, the other one will cut equally also. And again, they would still be in proportion. All right, and the last thing to look at is the triangle angle bisector theorem. It says that if we have a ray or a segment that bisects an angle of a triangle, and it divides it, the opposite side into two segments that are proportional to the other two sides. So we could say 8 is to 5 is x is to 6 and go across the triangles. We could also say 8 is to x as 5 is to 6 across this way, okay? So there's a couple of ways you can do the proportions. It's really up to you how you see it, but using this, dividing the segments into proportions, so 8 is to 5. So basically you're creating two similar triangles here as x is to 6. So 5x equals 48. And when you divide, x is going to equal to 9.6. Okay? Taking this one, 24, 40, x, and 30, I see that I have congruent angles, so I know that this is a ray or segment that's bisecting the angle, splitting my two sides here that it touches into proportional parts. So I could say that it's 24 is to 40 as x is to 30, all right, because you're always going back to where you originally got, so 24 to 40, x to 30. Okay, 40x equals, I think that's 720. Right, and then when you divide, you're going to get x equals 18. But you could have also did 24 is to x as 40 is to 30, and you'll get the same answer. So that's our angle triangle bisector theorem. And just one more to take a look at. If we have triangle ABC and QT is a parallel line, then we know that it cuts these triangles proportionally. So we have 5 is to 6 as 3 is to x, or 5 is to 3 as 6 is to x. You have a number of ways to do this. So we're going to go this way. 5 is to 3 as 6 is to x. It's all in proportion. 5x equals 18, and so x is going to be 3.6. But again, you could have also done 5 is to 6 as 3 is to x, and you're going to get the same thing. So the proportionality remains. Now again, I would use 5 and 6 again in order to help me find the y, because if I make a calculation error here and use it, I'll get another calculation error. So if I do 5 is to 6 as, so 5 is to 6 as 4 is to y. So starting with 5 here, I have to start with 4 here. So I'm going to get 5y equals 24. Divide by 5, and we're going to get that y is equal to 4.8. All right, so that's using proportionality in triangles, whether you have a line parallel to the side of the triangle, or if we have a ray or segment bisecting the angle of the triangle.